Welcome to the Cellix video channel. In this video, we'll look at setting your PID parameters. Cellix pumps have fast response time and achieve flow rates quicker than other pumps. However, it's not easy to get the ideal response time, so it takes some work and involvement on the part of the user. This work is done in setting the PID parameters, which control how the pump adjusts its flow to the desired rate. PID stands for proportional, integral, and derivative. These are the three factors which will help us achieve our desired flow rate, quickly and accurately. When you set a desired flow rate and start running your pump, the proportional parameter finds how far the flow is from the desired rate and increases the flow rate proportionally. The derivative parameter looks ahead to make sure the proportional parameter doesn't overshoot too much. As this process continues, it can reach a steady state at some distance from the desired flow rate. The integral parameter looks to reduce the steady state error to zero. Once these processes have completed, the desired flow rate is achieved. This applies to use cases where fast switching is necessary in your experiment. If it's not necessary, your pump will work just fine without you fine-tuning these parameters, but they do allow you greater control and greater performance from your pump. Note that if you have an Exco pump, you need a flow sensor to adjust PID parameters. Check out our website to learn more. Now, we'll look at tuning the PID parameters. The coefficients Kp, Ki, and Kd correspond to proportional, integral, and derivative respectively. First, set all parameters to 0. Then, increase Kp until the dynamic response of the pump is fast to your liking. If the Kp value is too high, your flow rate will start oscillating. Next, gradually increase Ki in order to minimize the steady state error. The ideal Ki value is between 0 and 1, but it's quite sensitive and can cause the system to oscillate at high values. So it's best to start at a value of 0.001. A value of 0.1 is likely too high and will probably cause the system to become unstable. Finally, if there's a large initial overshoot, increase the Kd value until you're happy with the result. A large value for Kd will reduce any overshoot almost entirely, but will come with the trade-off of a slower response time, so it's up to you to balance which is more important to your use case. So, now you know about PID, how it works, and how to tune the PID parameters. But if you have any further questions, check out our website at wearecellix.com or contact us using the info on screen or in the description below.